unmute yourself. Let the slide be like this only, sir. You share the slide, not an issue. Let it be like that. Yes, sir. Make it full screen, sir. Why? Because we can avoid doing again such a thing, sir.
Good afternoon to one and all present here. With the blessings of God and support from you all, I, Dr. N.V. Shishpa, Assistant Professor, Department of Chemistry, welcome you all for the valedictory function of 5-day virtual FDP program on Advanced Functional Material for Science and Engineering 2023. I take this opportunity to welcome our management, Shri B. Bailappa sir, President, Dynamic Education Trust, Shri B. Manjunath sir, Executive Director, DBIT, Shri Raghav Bailappa sir, Secretary, Dynamic Education Trust, Dr. Nataraj K.R., Dean and Director, R&D, our beloved Principal, Dr. B.S. Nagabhushan sir, Dr. B.S. Umashankar sir, our Vice Principal, our HOD, Dr. A.S. Manjunatha, and our distinguished keynote speaker, Dr. Arun M. Islu, respected dignitaries and dear participants. I once again welcome you all for the valedictory function. The session will start with the overview of FDP. The 5-day virtual FDP program started on 15th May with formal inaugural function followed by the keynote address by Dr. Palaniyappan, Principal Scientist, CSIR, on the topic Role of Advanced Carbon-Based Functional Materials in the Development of Electrochemical Sensors. The session 2 was from Dr. N. Satish, CSIR, on the topic Role of Advanced Functional Materials in Modern Electrochemical Energy Storage Devices. On day 2, the session 1 started with the speaker on the topic 2D materials nanocomposite for photocatalytic and electrocatalytic hydrogen evolution and other energy application by Dr. K. Pramoda from JNCSR. The session 2 was from Dr. S.T. Nandibevur, Professor, Department of Chemistry, KLE University, on the topic Development of Electroanalytical Techniques for the Determination of the Drugs at Graphite Pencil Electrode and their applications in aqueous media, a green chemistry approach. On day 3, the session 1 was from Professor Dr. Gurumurthy Hegde, Director, Center for Advanced Research and Development, and Professor, Department of Chemistry from Christ University, on topic Shape Anisotropic Materials and the Tuning to Innovative Applications. The session 2 was from Mr. Kumarswamy DR, Honorable Director, Prakriti Institute of Environmental Studies, on the topic Industrialization and its Impact on Society. On day 4, the session 1 was from Dr. S. Girish Kumar, RV College of Engineering, on the topic Doping Mechanism in Tri-Dope Titanium Oxide Observations and Contradictions. The session 2 was from Dr. Mahesh S. Padaki on the topic Membrane Technology for Future. The day 5, session 1 was from Dr. S. Nagaraju, Associate Professor at Energy Material Research Laboratory, Department of Chemistry, Siddhaganga Institute of Technology, Tumkuru, on the topic Advanced Nanostructured Materials for Lithium-ion Battery. Now the valedictory keynote speaker, Dr. Arun M. Islu, Professor, Department of Chemistry, will take over the session on advanced tailor-made materials for membrane application. With this overview, now I request our beloved principal, Dr. B. M. Nagabhushan sir, to speak few words. Sir, over to you, sir.
Thank you, madam. A very good afternoon to all the participants on the call. On the last day, the concluding day of this 5-day faculty development workshop on advanced materials for science and engineering. I cannot speak much on this particular topic because I'm not from the chemistry background, but nevertheless, I can speak something very general of sort of what I want to share with all the participants. To begin with, I'm very sort of thankful on behalf of the management of Don Bosco Institute of Technology to all the resource personnel who have shared their knowledge on quite a few sessions during the past 5 days, 4 days. Today is the last day. Looking at the spectrum of people who have been with us, of course, virtually. I was just looking at the organizations they hail from. It's in fact a good mix. We have representation from Government of India Research Establishment, CSIR labs, central universities, private universities, and also an organization from totally focused on environmental studies and other engineering colleges. This is a right mix where there is a key takeaway for every participant, because the knowledge comes out of all corners. So that way, in my opinion, the spectrum of the resource personnel who could contribute is a right mix. And in that regard, I am very thankful and grateful to the Department of Chemistry headed by Professor Manjunatha for getting a good mix of people for this workshop. I was also looking at the diversification in terms of topics. Even the title of the workshop itself is very catchy and sort of broad-based one. So the advanced material for science and engineering. So I think nothing other than this would have probably so aptly described the focus of this workshop. The reason being, in my opinion, advanced materials are on continuous quest in all possible spaces. Of course, we speak about some of these applications in any workshop, mostly on energy storage, supercapacitors, membrane technology, and others. But if you really see per se, and I'm sure people from the total core chemistry background would have the same opinion that this use and the quest for nanomaterials is for a multitude of applications, much beyond the type of application that we generally speak about. From that angle, the title of the workshop, the use of advanced materials for science and engineering, is very apt. And also in terms of technology, I believe people have spoken, and all the participants on this workshop, I expect to have become quite knowledgeable in terms of the material used, their characterization, both from the perspective of possibly the simulation techniques and also through analytics. And probably I don't think people would have spoken about this in the future. Typically, in my imagination, while the quest for newer materials and their characterization are very important, but they are the first two milestones in trying to understand the material itself. The reason is where we apply, what we do with that depends upon what the material is and how well they are characterized. What are the characteristics of this material? What is the static characteristics? What is the dynamic characteristics? How does it work under small signal inputs? How does it work under large signal input? These are some of the characterization which we have to do on any material. This generally will take us to the remaining steps, at least in my imagination. First, for application, where these materials can be used. Having said that on a broad outline, we have to build prototypes and then validate them on a smaller scale, so that, and then extrapolate it by way of back and forth experimentation. To finally say that these are the applications indeed which can employ these materials. So this is typically the cycle of development which any material would pass through. And what is really sort of emphasized, the way it is laid out, is in terms of the first 2 or 3 steps. However, I think the CSAR friend has spoken about the sensors, and some professors have spoken about the analytical techniques, and quite a few have spoken about the energy storage devices. And I understand there was one session on membrane technology and yet another session on lithium-ion batteries. So the quest for material, people have understood. Characterization, people have understood. What is missing is the next couple of steps where people have to use this to build samples, prototypes, be it a sensor, at the level of material and as a product, and also in the context of an application. So these things become very important moving further. I don't think this workshop, on account of time, probably would have not set focus on this. Why I am making this clear is that I sincerely urge that participants take this knowledge, go to their respective institutions, and pursue this as their research task. Only when we do that, at least in our opinion, as organizers of this workshop, we will be happy, because the participants, we could spawn an idea in each of these participants who have been a part of this workshop as participants. Why I am stressing this? Another reason. Many of these workshops generally take place 5 days, 3 days, or 2 weeks, fully jam-packed sessions, lectures, taking notes, deliberating, discussing, getting it clarified. Everything happens with high level of glitter, but afterwards everything sobers down. For various reasons, not that participants are not interested. They would be interested, otherwise they wouldn't have become a part of this workshop or any such workshops. Due to priorities, they get into some other activities in their respective institutions. But my sincere request is that at least in our institute, we are making it a point. We charge our faculty who participate in any of these such workshops, be it for 1 day, and even a faculty going out for 1 day industrial visit. So he is or she is asked to take it very seriously and then have a plan of action for this. From this generic requirement, it becomes very important for each one of you to take the knowledge that you have gained in this topic, go to the respective institutions and then have a plan of action. Let the knowledge grow. One of the sort of, it is a philosophical statement, but it is true that one of the global objective or a sort of philanthropic objective of any workshop is knowledge acquisition, knowledge generation, and knowledge dissemination. What we are doing as a part of workshop, we would have acquired some knowledge, not that we have fallen from the sky with specialized attributes, just that we organized few experts, stalwarts in their own respective fields, request them, could organize this. So the acquisition is tapped and then dissemination is organized. What do we have to do next? The knowledge has to be generated. How do we do that? If each one of our participants takes the outcome of this workshop and then have their own plan of action, small, good, medium, whatever order it is, it starts from a small seed value, but definitely it will grow to greater heights as time passes by. Having said that, each one of you, if you can take it, that leads to sort of knowledge generation. What happens to knowledge generation? So many of you would become experts, then you would become resource personnel in some other workshops. Then you start really disseminating knowledge. Again, somebody like you, as on today, would take that knowledge. Then it is a sort of iterative cycle where the whole knowledge grows into a big time vertical. So let's have that realization and make best use of the opportunity that you have got and best opportunity that we have got to organize this. So DBIT management has been very sort of philanthropic, having a philanthropic approach in enabling such events every now and then. And the objective is only this. So we are only organizing this and then siphoning this concept among the participants so that the knowledge grows, the subject grows into big time vertical, and we all see the progress in terms of growth in technology, growth in domain, growth in product profile, growth in the spectrum of applications, be it nanomaterial or any generic material or any other technology per se. One last thing specific to this particular field is that speaking about characterization of the materials, in my opinion, there are two ways of doing it. One is on the simulation front, and second is using specialized equipments. That is where the cost factor comes, especially for characterization. So you want to buy equipments, things are going to be pretty expensive. And a matter of encouragement within DBIT is that we are trying to set up one lab in our own frugal way. So once it becomes a reality, so probably our ambition is to look forward for such workshops with hands-on. In fact, Professor Manjunatha organized one such hands-on workshop for our students who don't have much knowledge on this, but for participants on this particular FDP, I'm sure we should come out with more serious case studies, experimentation, hands-on session. So we are trying to work in that direction. And we look forward for any sort of support from you as participants. And also we look forward for similar support from the resource personnel with whom we got connected through this workshop and would strive hard to retain and grow this collaborative sort of relationship with these institutions. Having said this, and once again, expressing my sincere gratitude to the management, firstly, and also to the resource personnel who have spent their valuable time in sharing their knowledge, and also all the participants who have really taken time off their schedule, and then having taken interest in getting into this learning sessions. So very grateful and thankful to all of you. And at the same time, so I hope that such things would become more frequent in our institute and also in your respective institutions as well. Last but not the least, but it's very important, I sincerely appeal, if there has been any snag, any sort of discomfort in you, in your sort of participation in this workshop, so we regret for that, and please do share your feedback. I'm sure there's going to be some feedback sessions. So do share your realistic feeling so that we are in a position to correct those mistakes and then see to it that when we organize such workshops, such mistakes do not recur again anytime in future. I wish all the participants the very best in their future endeavors after this workshop in taking the knowledge acquired through their research tasks. And I thank the organizers of this workshop to have given me an opportunity to speak on this occasion, say a few words of what I think should be done moving further. Thank you very much.
Thank you very much, sir, for your kind words and continuous support. Thank you very much, sir. Now, it's time to introduce our speaker, Dr. Arun N. Islet. Sir has obtained a PhD from Medicinal Chemistry from Bangalore University and postdoctorate from Technion in Israel Institute of Technology. Sir has 17 years of teaching and research experience. His research interests are on membrane technology, medicinal chemistry, organic electronics, nanomaterials, X-ray crystallography, organic synthesis, etc. Sir has 244 research publications and has attended more than 70 plus conferences. His Scopus H index is 34 and ITER index is 88 and citations is about 4,280. He has also got US patent, out of which he has 2 US patent granted, out of which 1 is published, and he has received 1 Indian patent. Sir has published many books, naming Green's Sustainable Process for Chemical and Environmental Engineering and Science, Supercritical Carbon Dioxide as Green Solvent, Advanced Nanomaterials for Membrane Synthesis and its Application, Inorganic Nanomedicines, from by Transtech Publisher. Sir has been guided 16 students for the PhD. Currently, 6 more are working. He is also a visiting scientist for Technion Israel Institute of Technology, School of Physics, University Science Malaysia, University Technology Malaysia, University of Waterloo, Canada, University of Toronto, Canada. To his credits, Sir has been awarded Sir C.V. Raman Young Scientist Award, State Award in Chemical Science on 2018. He was also selected for the award of Center of Excellence in membrane research by VGST, Government of Karnataka, during 2014 for amount of rupees 16 lakhs. He has been identified with the top 5 researcher in India as per Scopus survey held during March 2014. Sir has also received Certificate of Excellence in Reviewing from European Journal of Medicinal Chemistry for the year 2013. He has also received Certificate of Excellence in Reviewing from Desalination Journal of Elsewhere for the year 2012 and Best Research Paper Award for the year 2011 from VGST Karnataka in the year 2012 and also received Young Scientist Award from Board of Research in Nuclear Sciences, Department of Atomic Energy, Government of India in the year 2009. With this brief introduction, now I request our keynote speaker to take over the session. Sir, the session is to you, sir. Please take over the session, sir.
Okay, madam. I hope I'm audible to all of you.
Yes, sir. Audible, sir.
Yeah, just a second. Let me make it full screen.
So the screen has not been shared now, sir.
Yeah, is it now visible?
Yes, sir. It is visible, sir. Yes, sir.
Okay.
Please, please, sir, continue.
Thank you, madam, for introducing me. Very good afternoon to all of you. And I hope since last 4.5 days, you have gone through different sessions related to the nanomaterials, smart materials, energy storage devices, sensors, and many other advanced type of the materials. And I'd like to thank the principal, Dr. B.S. Nagbhushan, for his highly inspiring and motivational address during this valedictory. Thank you, sir. And I am also highly motivated and inspired by your valedictory address. For the next 40-45 minutes, I'll be talking about our small contribution in the research in the field of membrane technology. And the title is about advanced tailor-made materials for membrane applications. And first of all, I would like to acknowledge the Dr. Manjunatha, head of the department chemistry, DBIT, and Dr. Nagbhushan and the management, and also, of course, to Dr. Manjunatha and his team from DBIT. Of course, my acknowledgements to Director of NITK Surathkal for providing the research facility and wholehearted support for all my activities at NITK Surathkal. And one of my collaborator, Professor Ahmed Fauzi Ismail, who is the present Vice Chancellor at University Technology Malaysia. He is my collaborator since last 15 years. And of course, the generous funding from Department of Atomic Energy, Board for Research in Nuclear Sciences, Government of India, DRDO, Government of India, Department of Information Technology, Government of India, VGST, Government of Karnataka, and Ministry of Mines from Government of India for their generously funding. And of course, my sincere thanks to all my former as well as present group members. Earlier, about 19 candidates have successfully moved from my group with a PhD degree, and currently 7 more are working. Whatever the contributions by my group members, I am just presenting here. This is our the NITK campus. It's located in NH66. The NH66 you can observe in the picture 3, the aerial view of our campus, where the NH66, it is dividing our campus into western side campus and eastern side campus. On the western side campus, we have our own sea beach, and on the eastern side, many of the all the administrative as well as few of the academic blocks, academic buildings, and the hostels you can find on the eastern shore, on the eastern side of the campus. And throughout our campus, you can find hundreds of peacocks. Our campus is around almost about 300 acres which is at the outskirts of the Mangalore. I take this opportunity to invite you all to NITK Surathkal in the coming days. Suppose if you look at this handsome model, his perfectly fitted trouser or the shirt, these have been stitched by an expert tailor. And definitely, you know how the tailors will do. So first they will design, they will put a mark, they will make the required markings or the designs on the cloth, and then they will cut the cloth into required dimension and then stitching at the appropriate places. Myself as an organic chemist, we are doing almost the similar job as what the tailors are doing. But only the difference is we are not cutting any cloth, or we are not joining any of the stitching any of the cloth. But instead of that, we'll play with the small organic molecules. So the organic molecules we'll choose the appropriate type of the organic molecules, and then wherever required at the appropriate functionalities, we'll stitch them together, and that's how we get a larger required molecules. That's why the title talk I have placed as a tailor-made materials. That means the designing the materials of our required dimension or required type of the, as per our wish, we can make the these molecules. So the tailor-made materials, this terminology fits very well to our ongoing research. Let me salute these two great personalities. One is Professor Matsura on the second side, on the second photograph, who is basically from Japan, and he migrated to University of Ottawa sometime during the 1960s, and currently he is about 84-year-old, still very active in membrane research. And the second great personality, Professor Surirajan, who is basically from Tamil Nadu, who also migrated to University of Ottawa, Canada, sometime during the 60s. And both Professor Surirajan and Professor Takashi Matsura, they have immensely contributed in the field of membrane technology. And the present water purifiers, where generally the RO technology is being used, reverse osmosis technology was used. That is the contribution. It is because of the initial contributions by these two great personalities. Unfortunately, Professor Surirajan breathed his last during 2022 January month at the age of about 99 years old. So they are very popularly known as fathers of membrane technology across the globe. So as you know, in the hydrosphere, that is the total amount of water which is present on this universe, about 97% of the water, out of the total amount of the water, 97% is present in the form of the saline water in the oceans. And without the process called desalination, this water is unfit for any of our day-to-day applications, like it may be for the agricultural or it may be for the industrial purposes. For any of the applications, it is unfit without the desalination. And about 2% of the water which is present in the polar regions in the form of the solid ice. And then the water which we are using for our day-to-day applications like industries or residential or for the agricultural, the total contribution of this water on this universe is less than 1%. That means the freshwater streams or the freshwater river or the underground water, well water. So all these contribution is less than 1% on this universe. And as you know, because of the rapid urbanization and the industrialization, the demand for the potable water is growing like anything. Day by day, the demand for this potable water is going up. And sometimes the conflicts between our neighbors is because of the water only. Some of the pictures here which I have incorporated, these are self-explanatory picture. I think I need not give any more explanation about these pictures. Yeah, I was mentioning about regarding the water. Internationally also, the water is it's one of the important issue at even at the international level. And many times the conflicts between our neighbors is for sharing of the water. Maybe the people who are residing in the same apartment, or people who are staying in the same streets, is the conflicts is because of the sharing of the water, or the conflicts between the districts. Say for example, Dakshin Kannada district and Bangalore district, since last few years there is some conflicts is going on, and it is because of the sharing of the Netravati river water, or between Karnataka and our other neighboring states, or between India and with the other states, or even at across the Middle East and across the globe. The conflicts are because of the sharing of the water. That is the one of the major issue. That means it is not only just economically important, but politically also water is a very, very important topic now. And according to some scientists, by any chance, if there is a third world war, if it is going to take place, that will be only because of sharing of the water. So I think most of the participants are from the Bangalore. I think I need not mention any more information on this. The first photograph that is taken from the Bellandur Lake, and the lake has been contaminated, or it got polluted to such an extent that many times the froth which is formed from the contaminated water, that is blocking the road itself, that is blocking the highway. So there is a solution possible from the using the membranes. Or in the second picture, you can see the which are most common in residences or in offices. These type of water purifiers, again, these are based on the membranes only. That is ultrafiltration or nanofiltration or reverse osmosis based type of the membranes. And another one, that is even the fuel cells, you might have heard, where the anode and the cathodes, two electrodes which are separated by the semi-permeable membranes, which are nothing but the semi-permeable barriers are nothing but the membranes only. Only the difference is, in case of the fuel cell application, the membranes which are used, they are actually hydrophobic in nature. That means water repellent in nature. Or even in the automobile sector also, these membranes are quite common. Again, here also the hydrophobic type material. Or even in the biomedical applications, this is one such example where I have included the hemodialysis cartridge. So this hemodialysis cartridge, it works based on the principle of the membranes only. So I want to highlight that membranes are there in, you name any of the field where membranes are there. So that shows the importance of the membranes in our day-to-day applications. Now, let me define the membrane in a simple way. For the next another 5-7 minutes, I'll be speaking about some basic terminologies related to the membranes. And after that, I'll move to some of the advanced materials which will be useful for the membrane applications. So the membrane is nothing but, in a very simple way, we can define like this: any barrier which allows the passage of the selective component, and at the same time which hinders the passage of the unwanted components. That means it is a selective filter, we can say. In a simple way, it's a selective filter. Required materials are passed through it, and unwanted they will be filtered through that one. And based on the pore size as well as the operating pressure, membranes have been mainly classified in the 4 categories. The first one is MF, or nothing but the microfiltration membrane. Second one is ultrafiltration membrane. Third one is nanofiltration membrane. And the last one is the reverse osmosis membrane. In microfiltration membrane, it removes only the suspended microparticles. Only it can remove the suspended particles, and it has the pore size greater than 0.01 micrometers. Whereas in the ultrafiltration membrane, the pore size are still smaller, which are in between the 5 to 10 nanometers or 0.005 to 0.01 micrometers. So within that particular range. And for most of our industrial application, like it may be in the pharmaceutical industries for the separation of the isomers, or maybe in the hemodialysis cartridges, which are nothing but the hemodialyzers, or for the varieties of industrial application, including the water purification or the separation of the proteins, where the ultrafiltration membranes are widely useful. So industrially, the ultrafiltration is having lot of applications because of the wide range in the porosity. And then the next comes the nanofiltration membranes. And in the nanofiltration membranes, these are actually termed as hybrid membrane materials, because the porosity here, which is in between the ultrafiltration as well as the reverse osmosis type of the membrane. And here the pore size, which is between 0.01 to 0.005 micrometer or 1 to 5 nanometer. Similarly, the last one is the reverse osmosis membrane, which are nothing but which are also termed as the tight membranes, because these are not porous at all. The separation here, it will take place because of the diffusion. And you may be knowing in the diffusion, the very high pressure which will be applied here. So because of the diffusion, the separation of the, even at the ionic level, the separation can be carried out even in the reverse osmosis. So no doubt that the reverse osmosis membranes that can remove 99.99% of the any of the ions or the microorganisms present in the water. But now researchers are more focusing on a lot of work is going on in the field of nanofiltration membranes, because they want to perform the desalination or separation of the components from the fluid at low pressure. Because in the reverse osmosis, you can observe the required pressure is about 30 to 60 bar pressure, which is considered as very high energy consumption. Whereas in the nanofiltration membrane, it is below 30 bar pressure. That means these are much energy efficient. And in the nanofiltration membrane, actually they have a charged surface, and because of the Donan exclusion principle, the separation of the ions which will possible in the case of the nanofiltration. And NF membranes are considered as future membranes. So in future, the reverse osmosis may be completely replaced by the nanofiltration. Thereby, we can perform the filtration process even at a much economical price than that of the present price what we are utilizing for the energy consumption. So much cheaper rate, these may be possible in the future. So what could be the challenges in the membrane technology? So first of all, since we all are chemist people, most of us are chemists of the material background, the following are the few challenges. One must know this. The first one is choosing an appropriate stable material. So the appropriate choosing stable material, in the sense either it may be the mechanically it should be stable, it should be chemically stable, it should be more durable in nature. And then the preventing and minimizing the fouling. Fouling is nothing but once the membranes are used continuously for some duration of the time, maybe few hours or few days, and depending on the water quality, based on the contamination of the water or the fluid, the fine pores of the membrane, they get deposited by the these impurities which are present in the fluid. So because of the deposition of such impurities, their efficiency will greatly come down. So it is a challenge for the membrane technologists to either to prevent or to minimize the fouling which is taking place in the membrane. So our research group is mainly focusing on developing some novel materials to minimize the fouling. So thereby we can enhance the lifespan of these membranes. And of course, retaining a high flux. Flux is nothing but the flow rate per unit area in a given time, and then high selectivity. That means increasing the specific nature of the membrane towards the specific type of the ions or the contaminants which are present in the fluid. That means keeping a high selectivity. And then, of course, maintaining a proper balance between hydrophilic nature and hydrophobicity. So depending upon our application, we can either enhance the hydrophilicity or we can enhance the hydrophobicity depending on our application. So a proper balancing should be made. And of course, the another economically important is making all these processes more cheaper or more economical, so that even a common people can afford this particular technology. If these technologies are too expensive and if they are beyond the reach of a common person, then what is the importance of developing such technologies? So to make it more efficient, more economical is also the challenge. Of course, the application-wise, either desalination, wastewater treatment, biomedical, pharmaceutical, dairy industry, wastewater treatment, you name any of the field where the membranes are useful. What are the qualities of a good membrane material? Because in the market, there are hundreds of different polymeric materials are available. And all those polymeric materials which are available in the market, they are not fit for the membrane application. So the given material, if it shows the following qualities, then we can say that this material or this particular polymer is suitable for the membrane application. The first one is film forming nature. It should have a film forming nature. It should tolerate the mechanical strength to overcome the high pressure which is applied during the membrane operation or during the performance. The thermal stability, this is particularly while sometimes the industrial wastewater, which will be where the temperature of the industrial wastewater may be more than 40-45 degrees Celsius. So in such case, if directly the industrial wastewater, if it is used for the filtration, it should not destroy the membrane material because of the increased temperature. So thermal stability should be there. Chemical stability, because the wastewater may contain varieties of the chemical waste components also. So that should not affect the performance of the membrane. So chemical stability, proper balance in the hydrophilicity and hydrophobicity. So these are some of the listed polymers like polysulfone, polyether sulfone, polyacrylonitrile, the polyvinylidene fluoride, these chitosan, these are some 7-8 polymeric materials which are most commonly used in the membrane fabrication. The reason is most of the above required qualities, these are satisfied by or these are exhibited by the listed polymers. But none of the polymer example which is listed here is completely fulfilling the above qualities. There are one or the other drawbacks are there. There comes the importance of the organic chemists or the chemistry people or the material science people who can modify the properties of the polymers as per our required type of the applications. So some of the materials like the PVDF structure which I have presented here, PVDF or polyether sulfone or the polyphenyl sulfone, so or polysulfone, these are all excellent materials. But when it comes to the hydrophilicity nature, their hydrophilic property is comparatively much lesser. Because if our application is focusing on the water purification, in such case, the hydrophilic nature has to be incorporated or it should be improved. Otherwise, that will directly affect the performance of the membrane. Let us see how these membranes can be prepared. This is an automated instrument which we are using in our laboratory. For a beginner, even they can start with just by investing something about 500 to 600 rupees. They can begin with even with the simple a glass plate and one of the stainless steel rod, or which is also called as doctor's blade or casting knife. So this requires already about 500 to 600 rupees. That is for the beginners. However, this automated instrument, automated instrument, here we can fabricate the membranes very precisely of about 25 micron, 50 micron or 100 micron thickness. But for the beginners, if you don't have the sufficient funding, then you can start with the as I mentioned, with the glass plate and a stainless steel or a glass rod. With the help of that one can begin. The procedure is very simple. First, prepare the polymer solution as per the required viscosity, and after preparing the polymer solution, you can introduce it on the glass plate which is mounted on this automated instrument, and then there is an arrangement through which the polymer solution which is introduced on this glass plate, which can be uniformly spreaded across the glass plate with this automated moving doctor's blade. With the help of that, the uniform movement, the polymer solution will be uniformly, it gets spread on the glass plate. And after that, remove the glass plate and immerse it in a container which is containing the distilled water. And within few minutes, the membrane separation of the polymeric membrane which will take place. So now this membrane, whatever the separated membrane or the film is there, that you can send it for the analysis. So this is a cross-sectional picture of a flat sheet membrane which was fabricated. Of course, there are different parameters such as what type of the polymer was used, what type of the additives were used, what is the viscosity of the solution, what is the temperature. So these are all there are many factors which are actually influencing the pore size and the qualities of the membranes. And the second type, this is nothing but the hollow fiber membranes. These are gaining in the recent years, last 1.5 decades. In last 1.5 decades, the hollow fiber membranes are gaining more and more importance. The picture you can see in the first picture here, these are the hollow fiber membranes, and these hollow fiber membranes, they are actually looks like a noodles, very thin long noodles. Only thing is the inner part is completely hollow. It's like a tube, just like a tube is a hollow. In the similar way, these fibers are hollow, completely hollow tubes, and the diameters, again, it varies. It can be from 200 to up to 800 or 1000 micron in diameter. So based on our requirement also, these can be designed. So this is a schematic diagram for the fabrication of the hollow fiber membranes. So recently in NITK, we have installed this particular large scale hollow fiber membrane making machine, and per hour about 650 to 700 meters of the membrane can be fabricated per hour without any interruption. And we'll extend this facility to any of the researchers. So this was procured in NITK Surathkal under Central for Research Facility called CRF. Not only this hollow fiber membrane making instrument, but also we have about 25 to 30 high-ended equipments, and those equipments we are also giving it for any researchers from any of the institutions. So you can refer through the Google NITK, CRF. So you can find the list of the equipments, and you can book the slots online also. So there is a nominal charges. So you can make use of the facility at the CRF. Even we'll extend for the hollow fiber membrane fabrications also. And this is a cross-sectional picture of a typical hollow fiber membrane. On the right side, you can say it's a inner core. The dark colored core is completely hollow, and the outer, the region which is highly porous, through which the percolation of the fluid which will take place. This is the cross-sectional picture of a hollow fiber membranes which were fabricated in our laboratory. And again, in the next few years, next 8 or 10 years or so, I strongly believe that flat sheet may be completely replaced by the hollow fiber membranes, because the hollow fiber membranes have many advantages. Like first of all, the surface area is very large. So due to the larger surface area, the hollow fiber membranes require very small space. The space required for hollow fiber membrane cartridges very small due to the high surface area. And second one is due to the cross flow, the lifespan of the membrane is also much longer than that of the flat sheet membranes. So in the coming years, the hollow fiber membranes will be, no doubt that the hollow fiber membranes will become, they may replace the flat sheet membranes. Let us see, as I mentioned, our research group is mainly focusing on developing of the anti-fouling materials and the tailor-made materials for the membrane application. So we are into developing the different type of the materials. Among that, the hollow fiber, the flat sheet, the nano materials also. And always we wanted to something different from that of the other research group, because the moment nanomaterials means you might have seen hundreds of papers which are about graphene oxide, only the graphene oxide, or only about the carbon nanoparticles or carbon nanotubes, or TiO2 based nanomaterials. So we wanted to something different here. So the method for the fabrication, let us see in the conventional method what are the drawbacks in the conventional method for the nanomaterial fabrication, general difficulties or the general drawbacks in the conventional method. Generally, the longer preparation and harsh reaction conditions, or difficult to disperse during any of the reaction, and generally the size is also non-uniform in few of the cases, not all the cases. In few of the cases, the size is not uniform. And then the further modification, if you want to some functionality you want to introduce on the nanoparticles synthesized by the conventional method, which is very difficult. And then generally it ends up with the gel or the coagulum. So in such case, again, the isolation of the material is also difficult. And here we have adopted another reported method only, that is called as distillation precipitation polymerization. And in this one, as compared to the conventional, it's a very simple process, and there is no any harsh conditions or the chemicals as that of the conventional one. And the dispersion is much easier in either in organic or in the aqueous phase. More or less uniform size particles you can get. And due to residual vinyl groups on the core surface, that means vinyl groups or the double bonds, the further modification is much easier. If you want to introduce some functionalities, it is much easier in DPP method. So, and also the biocompatible cross-linker can enhance the hydrophilicity and the cross-linkings. So these of the few of the mentioned point, because of this plus or the advantages, nowadays research groups are focusing on this one. So our research group, we have started working on this particular DPP since last 3.5-4 years, and I give the credit to my group member, former group member, Dr. Syed Ibrahim, currently who is in University of Nebraska, United States, as a postdoctoral fellow there. So this is one such a material which we have synthesized in our laboratory, and then it was incorporated into while fabricating the membrane, and particularly for the hollow fiber membranes. And these membranes have showed excellent properties of dye removal for the removal of the dye present in the wastewater. Let me just keep that. Yeah, this is the scheme for the synthesis of the zwitterionic hollow fiber, zwitterionic polymeric nanoparticle. The term zwitterionic, I mean to say, just like that of the amino acids, which are zwitterions, which has both positive and the negative charges. And these are not normally the nanoparticle, but these are the zwitterionic polymeric nanoparticles. So if you in the Google also, if you hit this one, you will find very few papers on this. So the starting material, those who are interested, they can go through our published paper. So this is one such novel zwitterionic nanoparticle which was fabricated. Here we have used the two different monomers. So one is SBMA, which is nothing but the sulfobutane, and another one is bisacrylamide, that is MBAA. This one, the second one, the blue color, and in the distillation precipitation polymerization, the method was DPP. That's what. And here the AIBN was used as an initiator, and then acetonitrile ACN was used as a solvent here. And initially these were these were taken in a calculated amount of these reactants, including the monomers. They were introduced in a dry RB flask, and then nitrogen was passed for about 25-30 minutes to make it free from the oxygen. And then once that was done, then the reaction mixture was initially it was heated for about 75 degrees Celsius. And then meanwhile, this will be also connected to Dean and Stark receiver, because during the refluxing, the solvent, that is acetonitrile, excess of the acetonitrile to be collected out. So it is connected to Dean and Stark apparatus or the receiver, and then temperature later slowly increased to 100 degrees Celsius. And once about 35 ml of the acetonitrile get collected in the Dean and Stark apparatus, then the reaction mixture was removed out. It is allowed to cool to the room temperature, and then the nanoparticles were filtered and dried. So this is how the zwitterionic polymer nanoparticles which we have prepared. And then of course all the required characterization, such as the FTIR or the elemental mapping, which shows the elemental mapping, you can see here, showed the presence of carbon, nitrogen, oxygen, and as well as the sulfur, and also with the FESM and also with the TEM, also they have been characterized. Then after that, the TGA, the thermal properties, and also the XRD pattern also indicated these particles are somewhat crystalline in nature. And then of course their particle sizing and the zeta potential was also measured. And the zeta potential value, it was found to be about minus 47.7 millivolts. And the particle sizing through the particle sizing analyzer instrument, it showed about approximately around 331 nanometer. Whereas in the FESM, it showed less than 50 nanometer, when here it has showed about 331 nanometer. You may ask the question here. The reason is when this is suspended in the water, distilled water or the deionized water, the particles makes a hydrodynamic, because of the development of the hydrodynamic bond or the hydrodynamic bondings or the attraction, the particle size will be appearing as a larger in the this particular analysis. Hence the size is always larger. Then of course these were incorporated into polymer matrix, and then they were the hollow fiber membranes were fabricated using the this particular material as an additive. And you can see here the long elongated finger-like projections, which are nothing but the micro voids, and through which actually the percolation or the separation of the fluid and the unwanted component which actually take place. And these membranes were used for the testing the permeability of the two dyes, namely RB5 and the RO16. In RB5, it showed about uh, almost about 99% remol, and in RO16 it showed about 93-94 percentage remol. It is mainly because of the size exclusion. And of course, this work we have compared with the other type of the membranes, ultrafiltration membranes, which were fabricated and reported by the other research groups. So our membranes were found to be more superior as compared to the others, the membranes reported by other groups across the globe in terms of the its shelf life, or in terms of the rejection, or in terms of the uh, efficiency of these membranes. Then second one is the continuation of this one, the slight modification, because as you know, many of the researchers across the globe, they are working on the graphene oxide. And as I mentioned, we wanted to be something different from that of the regular the graphene oxide type of the work. So we wanted our main strategy, our applied strategy here was the graphene oxide, which are known to improve the hydrophilic nature, as well as they give the more mechanical stability to the membranes. And then the zwitterionic polymer nanoparticles, which were fabricated in the previous one, they also can incorporate, they can enhance the hydrophilicity, and they can improve the anti-fouling nature. So we wanted to introduce both these properties together. So here in this particular strategy, we have we have synthesized the graphene oxide in our laboratory using the graphite and treating with the KMnO4 and in presence of the sulfuric acid, the graphene oxide. And then the zwitterionic polymer nanoparticles were chemically bonded, which you can see here. This is what in the graphical abstract you can see. The zwitterionic nanoparticles, they were chemically bonded on this graphene oxide sheet, GO sheet. That was in the scientific report during the 2020. So this is the particular strategy. Here the GO which was synthesized in our laboratory, and then other two same monomers as that of the previous work. Then of course the various characterizations, the required characterization, including the FTIR, which has confirmed the formation of the GO, which is modified by zwitterionic polymer nanoparticle. And then of course other characterizations with the TEM also carried out, and also the EDAX, which has again showed the presence of carbon, nitrogen, elemental mapping, that is oxygen as well as the sulfur. And then the PXRD pattern, the XRD pattern, which again showed somewhat crystalline in nature. And then these materials, even for the XPS also, which again showed the XPS has again confirmed the type of the bondings which are present in the this novel material. Then these were incorporated in the polymer matrix, and then flat sheet, the hollow fiber membranes were fabricated. And you can see here the TM0 to TM3, where the contact angle, higher the contact angle, the hydrophilicity is lesser. So higher the lower the contact angle, that means TM2, the hydrophilic nature is more. So the TM2 is found to be more hydrophilic in nature. And these are the other properties, that is the porosity, the water uptake nature. And again, higher the water uptake means the better is the hydrophilic nature. And then again, the dyes were attempted for the RB5 as well as the RO16. So here you can see the removal of the RO16 that has came to around 74%, whereas the RB5 it is about almost about 99%. Again, because of the size exclusion, the RB5 molecule is much larger than that of the RO16 type of the dye molecule. You can see here the RB5 is much larger. The RB5 molecule is much larger. RO16 that can pass through this one. So the more rejection percentage was observed for the RB5 than that of the RB16. You can see the structures also which are given here. Then again, the anti-fouling properties were also studied. The polymer, the membranes which are containing graphene oxide modified zwitterionic nanoparticles as an additive, where the fouling was found to be significantly lesser. That means the added material acted as a anti-fouling material. So thereby the lifespan of the membrane is again much higher. So this also we have compared with the other researchers, and on compare with the other properties with respect to the other researchers across the globe. So our membranes were found to be much superior. And another one was again by Syed only. Here, the integration of the zwitterionic polymer nanoparticles in the interfacial polymerization for the ionic separation that was actually carried out. So those who are interested, they can go through the applied polymer materials, which was published during the 2020 under the ACS. So this was the typical strategy which was employed here. So the monomer here is different. One of the big acrylamide is the same bisacrylamide. Another was instead of the sulfobutane, we have used this SVBS, this particular monomer. And once the DPP, distillation precipitation polymerization, under the same condition as the previous, and then this was actually the formed zwitterionic particle that was reacted with the L-cysteine, one of the amino acid, which we have commercially procured, and that was treated. And you can see the zwitterionic polymer nanoparticles which were chemically binded to the L-cysteine amino acid. So this particular additive has further improved the performance of this material. So of course, the bed surface area, which was used for the characterization of this material, and this is actually for the red colored shows the more efficient one, and FTR before and after. Then similarly, the TEM images, there is some sort of agglomeration of those nanoparticles. The more or less the particles were lesser than 50 nanometer size. And similarly, the XPS also has confirmed the type of the bondings which are present in the these newly synthesized nanomaterials or polymer nanoparticles of the materials. And these materials were incorporated into polymer matrix, and flat sheet membranes were fabricated. So these were the different flat sheet membranes which were fabricated using the above synthesized materials. And the AFM studies which were performed, it showed the wherever the more additives were present, the roughness, more roughness, the higher the roughness, the filtration is found to be better filtration in the more rough surface areas. Similarly, the zeta potential, and then the characterization. This is actually done for these were used for fabricate the nanofiltration membranes, and they have showed we have tried different type of the salt solution where sodium sulfate and the magnesium sulfate, and at the same time these were also with the sodium chloride and the magnesium chloride also they were compared. Of course, they have showed the better result for the removal of the heavy metals up to about cadmium about 95 percentile and lead about 99.99 plus percentage of for the lead material. And then another was the catalyst and stabilizer free rational synthesis of the ionic polymer nanoparticle for the oil water separation of membranes, oil water separation membranes. So this was in ACS applied materials and interfaces during the last year. This was published, this particular one, and here the separation of oil present in the water, that is a separation in an efficient way, economic way, that's a great challenge. So these fabricated newly fabricated membranes, they showed excellent properties for separation of the different type of the hydrocarbons or the oils which are present in the water. You can see the results at the later stage. So this is the strategy which we have employed for the synthesis of these nanoparticles, polymeric nanoparticles. Those who are interested, again, they can go through our reference for the detailed synthesis and all the characterization with the XPS characterization as well as the TM, the other FTIR characterization, and also the filtration for the pure water flux was also carried out. XRD was also performed. So all the required characterization for this material was performed, and these were fabricated. These were used for fabrication of the flat sheet membrane. You can see the long elongated structures on the from the top region to the bottom of these membranes. Let me show directly this is the one. You can see here this particular the second bottle. This is actually this is the nothing but the pure one, the digital photographic image of kerosene water and the diesel water. So different kW for the kerosene water. You can see here, this is the kerosene water feed and this is the filter rate. That means the kerosene which was removed from the water. This is diesel water and this is the purified. And then the next one is the hexane water. So this is the purified. Similarly, the toluene water. So this is the purified one. So the size of these tailor-made nanoparticles were less than 100 nanometer. And DPP is the one of the best method for synthesizing such zwitterionic polymer nanoparticle. And the anti-fouling performance of these membranes was highly significant due to the such type of usage of the additives, and the dye rejection was up to about 99% in most of the cases, up to about 99% in all the previous materials we can say. That is mainly because of the zwitterionic polymer nanoparticles. They have significantly played role in improving the performance of these membranes. So in these materials also may be useful in other biomedical as other applications or even in the smart materials also. So those results are also under we are working on that. Hopefully in the next some interaction I'll come out with the other applications of those zwitterionic materials which are fabricated in our group. So this is the last slide. So I would like to thank the organizers once again, and thanks to all the participants. This slide was taken in the Dead Sea of Israel, and that Dead Sea is known. It's not a sea actually, but it's a lake, and it's about 60 square kilometers spread across the Israel, Jordan, and the Palestine region. The speciality is even a person, if any person who don't know the swimming, they can also easily float on the water, because the water is highly dense one. And in a regular ocean, there is a presence of the salinities because of the sodium chloride. But in the Dead Sea of the water, the salinity is because of the potassium bromide. And the water is highly dense and highly saline. So at such a high salinity, not a single microorganism is also reported. So hence the name is called as Dead Sea. So over to the organizers. And if there are any quick questions, I'll try my best to answer. Thank you.
Thank you, sir. If any queries, please put it in the chat box so that sir can answer your questions. Any queries? Sir, actually, it has been muted to everyone, so we are just waiting for them. Yes, sir, there is one question. Shall I read it out, sir?
Yeah, please.
Yeah. What polymers are most suitable for water purification and oil water separation application? Can it be possible to use natural polymers such as, sir, what is that?
Such as
Chitosan, or it
such
was
as,
not clear.
They can directly, okay, such as chitosan, or we should use the synthetic.
Chitosan, or we should use semi-synthetic polymers, and why?
Yeah, I think this is asked by Dilip Kumar Vijay. This is a good question. Of course, the natural polymers also can be used for not only for oil water separation, but for the other varieties of like the desalination maybe, or heavy metal removal, or protein separation, etc. But only thing is, the major drawback with the chitosan, or chitosan particularly, yeah, the main drawback with the chitosan is their mechanical property is very poor, because when these membranes are pressure driven, when you apply some pressure, the membranes or the films which are fabricated by the chitosan, they are very fragile, so they'll break within a moment. The complete breakage or the destruction of the membrane will take place. So of course, if you can try to make a blend with the chitosan with the other polymers. Of course, that is also not so easier, because the chitosan is it dissolves in the aqueous acetic acid, whereas other polymers like polysulfone, PVDF, they are soluble only in the organic solvents. But still, the blend can be attempted. We have reported that long back in one of the prestigious journal. And then another solution what I would like to give is the chitosan. You can make cross-linking in the chitosan polymer using either glutaraldehyde or some chlorous acid, or some binding agent, and those cross-linked polymers have somewhat better mechanical properties than the regular chitosan. Otherwise, cellulose acetate can be attempted. The earlier the commercially available RO membranes, they were made of the cellulose acetate only. That also can be used. But if you are particular about chitosan, then make it a cross-linked chitosan, or with the suitable blending. Otherwise, even at 1 bar pressure, the polymer membrane will easily get breaks. Yeah. Dr. Manjunath, I saw someone has raised their hand. I think Dr. Manjunath.
So Manjunath sir, any questions from your side, sir?
Someone has raised. Sir, no. One person by name Manjunath, I saw one.
Sir, there is one more question. Sir, yeah. Can you suggest any natural filters for purify the water to drink water?
Suggest any natural filters for purify the water to drink water. I could not understand the question clearly. Dr. Hemlata, can you can unmute and you can try to get it clear. the question
So
you
just
can
a
ask.
minute, sir. I'll give permission to her.
Yeah, yeah. Any other questions from, you can write in the chat box, or you can directly interact also.
Madam, can you raise your hand so that I can unmute you?
Yeah, please. Fine. What is the HD filter? I didn't get. Dr. Sharanabasappa Patil.
HD filters cost is very high. Can we make it?
What is meant by HD? I could not understand here. HD filter. Okay, there is a question from. Meanwhile, I'll go to the next question. Please write give the full form of the HD. I could not understand. Is it high density, or I could not understand that. We can use synthetic polymers, but to dissolve such as cellulose acetate, it is soluble in acetone, but other polymers might dissolve in DMSO. Exactly. So how good is to use such polymers? Will it not affect the water again? So while preparing the chitosan or the cellulose acetate, here the major challenge is if you want to blend it with the other polymers, the blending is not so easier, because the solubility of this one is a different solvent. Particularly if it is an aqueous based and the one is organic based, then the miscibility is highly difficult. Even in spite of that also, the miscibility up to about 5 to 6% of the aqueous soluble polymer can be miscible, that can be made to dissolve in the other organic solvent, but not more than 5 to 7%. That is possible. And here you mentioned about how good it is to use such polymers. Will it not affect the water again? So these the membranes, either in the flat sheet or in the hollow fiber, there is no any leaching out of the material. If there is a leaching out of the material, particularly if there are the additives, the improper type of the miscibility, if it is done, only in such case there is a leaching possibility through the membranes. It is possible. So if it is a uniform blend, then there is no any such type of the leaching. So it can be used for the water purification, even for drinking purposes. Dr. Sharanabasappa, can you mention what is the HD, so that I can answer your this one, and also Dr. Hemlata also?
Sir, I have given mic permission.
Yeah. Yeah. What is the recyclability of the polymer composite nanoparticles compared to nanoparticles as such? Polymer, you mean to membranes, Dr. Chamraj? Recyclability of the polymer composite nanoparticles. Yeah, there is no any this one, the recyclability as such. The polymer nanoparticles will be incorporated, or they will be used just like any other nanoparticles. The recyclability, it comes with respect to the membranes, how many times the membrane can be reused. But these polymer nanoparticles, just like any nanoparticles which you are using, in the similar way, these polymer nanoparticles also. Okay, in dye degradation. So this is by Dr. Chamraj. What is the recyclability? Yeah, that's what I think I have answered your question, Dr. Chamraj. Whether in any application, these nanoparticles, just like in other way, the nanoparticles what we are using, these nanoparticles like 0.5% or 0.01%, at a very small concentration, they will be added into polymer matrix as additives, just like any other nanoparticles. So there is no any recycling or recyclability of these nanoparticles, but the recycling or the reusage of the membranes, that can be done. That means the properly handled membrane can be used for about 3 to 6 years, ultrafiltration membrane generally. Dr. Hemlata, are you there?
I've given mic permission, sir. So shall we?
Okay,
Yes,
let
sir,
me
yes.
try to answer her. She had not clarified what type of the natural materials it is. But varieties of the natural materials, even like the sponge, the naturally available sponge, so which was also used for for the purification of the water. But any such natural materials, they can remove only the suspended particles. Only the suspended particles. They cannot remove the microorganisms. But the ultrafiltration, reverse osmosis, definitely. Along with reverse osmosis, the ultrafiltration membranes, they can also remove the microorganisms up to the extent of 99.99%. Whereas the natural materials, like it may be the sponge or other adsorbing material, other different type of the minerals which can absorb, but they cannot remove the microorganism. Even the charcoal is being used. Charcoal or the activated charcoal or the normal charcoal also is used for this filtration, but that cannot remove the microorganism. It can remove the any coloring agents or any of the chemicals that can be removed by adsorption, but it cannot remove the microorganisms. But in the case of membranes, even microorganisms can be removed. Yes, Dr. Chamraj. Yeah, anything? Dr. Chamraj, I think, wanted to speak.
Chamraj, sir.
Good evening, sir. Sir, I am audible.
Good evening. Yeah, please.
Yeah, nice presentation, sir. Very informative. Thank you for
you.
that. Sir, I have one more question. Suppose if you are going to synthesize some nanoparticles using plant materials as accident, if
Okay.
that possessing some antibacterial or antifungal characters, suppose if you are going to impregnate that nanoparticles in polymer,
Yeah.
Is it possessing the same nature? Or it gives any for that filtration purpose to remove the bacteria?
Definitely.
Is it possible?
Yeah, definitely. It's a good question. What I understood was by adding some plant-based or any other nanoparticles, whether that also can act like an antimicrobial nature, right?
Yes.
That's
Yes, sir.
Yeah, this is possible. Varieties of the even directly the pharmaceutical compound, different type of the antibiotics have been already which have been practiced by many people. And
Yes.
for your kind information about sometime 2018, I guess 17 or 18, you can find one of our paper in which was published in Journal of Material Chemistry A, JMCA, under the RSA, where we have used the polydopamine material. And this polydopamine material, the main intention was to destroy the microorganism, because of course the membranes has a property to filter off the nanoparticle, the microorganisms,
Yes.
right? But
Yes.
at the same time, our intention was, suppose to this membrane surface, if any contaminated water comes in contact with this surface, it should get destroyed. So we have attempted that one with the using the polydopamine material, and polydopamine material is an excellent material which has a already antimicrobial property. It adheres strongly, and it is a non-toxic to the human being. And that work was we have already reported. It is possible. You can refer our JMCA 2017 or 15 or 17. I don't remember exactly.
Okay,
You can
sir,
just
okay.
put polydopamine Aruna Mislur in Google. You may get that paper. Likewise,
Sure.
other nanoparticles, other antibiotics also can be attempted.
Yes, sir. We have attempted for antibiotics, so removal of antibiotic by using nanoparticles.
Yeah.
For some drugs. I have that question. If you are going to imprisonate that nanoparticles in a polymeric membrane, maybe that is also going to remove that bacteria.
Yeah, true. That can destroy actually. The membrane
Yes,
will
sir.
be anyhow, it will filter. So this will, the such nanoparticles which have highly antimicrobial properties, they will destroy, they will kill those microorganisms.
Okay. Thank you, sir.
Yeah.
So thank you very much, sir. I hope so. It was very informative, and our participants have participated very actively. So thank you for accepting our invitation. It was a very good session, and thanks for sharing your knowledge with us, sir. Thank you very much, sir.
Thank you, madam. And I would like to thank also, because I'm in presently today, I'm in Belgaum, Jain College of Engineering, Belgaum, for some other FDP. This morning I gave about almost 2.5 hour interaction, 2.5 to 3 hours interaction was there. And I have requested them to make an arrangement for me to this afternoon online session. So immediately after the lunch, I could join for this. So they have arranged. I would like to thank from the organizers from Jain College of Engineering, Belgaum, for arranging this and providing this facility. And madam, you have requested for some questions. When I can share those questions?
Yes, sir.
5 questions were.
Sir, can you, sir, please share it in the mail, sir, so that will be having the same in the feedback, so they will answer the questions.
Okay, can you send one email to me or Dr. Manjunath, Dr. I think I have.
So the Krishna madam will send you a mail, sir. So
Okay,
in that,
yeah.
please reply back the same, sir.
Yeah, can I expect a mail right now within 1 or 2 minutes?
So that we'll be sending within 5 minutes, sir. We'll be sending.
Yeah, madam. Thank you. Thank you.
Yes, sir. Thank you for accepting our invitation, sir. With lot of effort, you have been somewhere and on accepting our invitation. You have done this. Thank you very much, sir.
Thank you very much for this invitation and the arrangements. Thank you. Bye.
Thank you, sir. Yes.
Thank you, sir.
Thank you.
Yeah, dear participants, we would like to hear some of the feedback. So if anyone is interested, please raise your hand. Sir, actually, Ajay sir, you have been unmuted, so you can have that, please. Chamraj sir, you please share first, and Ajay sir, please share it in the after Chamraj sir. So Chamraj sir, you can unmute, sir.
Yeah, thank you, madam. Hello.
Sir, good afternoon, sir.
Hello, good evening. Good evening to all.
Yes.
Yeah, first I would like to thank Dr. Manjunath and also his team organized this nice FDP. And also I observed that all the things going on smoothly in time and correct time they start the sessions without any interruptions. And speakers selected are given that well informative sessions in all the 5 days. Thank you for the Thank you for organizing such a FDP. Thank you, sir. Thank you, Manjunath, sir. And thank you to all the team.
So thank you very much, sir, for your kind words. Thank you, sir. Sir, Rajay, sir, can you unmute yourself, sir?
Thank you, ma'am. And good evening to one and all. I'm Ajay Pratap Singh Galwar, Associate Professor, Physics Department, Deshbandhu College, University of Delhi. So I would like to express my heartfelt appreciation for the faculty development program that I had the opportunity to participate in. It has been an incredibly enriching and transformative experience for me. First and foremost, I want to commend the organizers and resource persons for their exceptional expertise and dedication throughout the program. Their knowledge and passion for research were evident in every session. The program content was well structured and comprehensive, covering a wide range of relevant topics in advanced functional materials. I particularly appreciate the emphasis on sensing, supercapacitor, and lithium-ion battery topics. Furthermore, the program's organization were commendable, although there were some technical glitches in last few sessions, but overall the FDP program was well managed. I suggest organizers to provide all PPTs of resource persons for easy reference. Overall, I am extremely grateful for the opportunity to participate in this faculty development program. It has not only expanded my knowledge and skills as an educator, but also reignited my passion for research. I'm confident that the insights gained from this program will have a positive impact on my students' learning outcomes. Once again, I extend my sincere thanks to the resource persons and organizers for their outstanding efforts in designing and delivering this program. Thanks.
Sir, thank you for your wonderful feedback, sir. And we will take out the suggestions given by you also, sir. Thank you very much, sir. Now it's time to give the vote of thanks. Our HOD, Dr. Manjunatha AS, I request him to propose the vote of thanks. Sir, over to you.
Yeah, thank you, ma'am. Good evening, all. I take this privilege and great honor to propose the vote of thanks on this memorable occasion as a convener on behalf of Department of Chemistry, Don Bosco Institute of Technology, Bangalore. First, I would like to thank our kind-hearted management for their continuous support for organizing this FDP. Special thanks to Dr. Arunya Mistur, Professor NITK Suratkal, who attended the FTP as a chief guest and delivered a talk, who despite his busy schedule has found to grace this occasion. Thank you, sir. I express my heartfelt thanks to our beloved principal, vice principal, dean and director R&D, HODs of various departments for their valuable contribution to organize this faculty development program. Thank you, sir. I owe special gratitude to all the eminent speakers for delivering a talk in our faculty development program in their busy schedule for enlightening all the participants in the area of advanced functional materials for science and engineering. I thank all the speakers. I thank my colleagues and organizers of this event, Professor Krishnaveni, Dr. Sushma, Mr. Shivraj, Professor Chinmayi, and Vidya Madam, and Mr. Sudeep and Krishnan, who have worked hard to ensure that this occasion becomes a memorable success. Thank you all. Last but not the least, I thank all the participants for your patience, listen, cooperation, and continuous participation for all the 5 days in making this function as a resound success. I thank all the participants. Thank you all.
Thank you very much, sir. The feedback link will be shared in the WhatsApp group for today's session, and overall feedback will be shared. The feedback will be shared tomorrow in the WhatsApp group. Please give us your valuable feedback. Once the overall feedback has been filled, you will get the e-certificate for attending this program. So we would like to thank all the participants for their support, which has been given continuously. Thank you very much for making this FDP a successful one. Thank you very much. The feedback will be shared in the WhatsApp group for today's session and overall feedback. So it will be shared by tomorrow, so that please wait till tomorrow. So we'll be sharing the feedback tomorrow in the WhatsApp group. Yes, with your permission, shall we end the FDP? So now it's time to end the meeting. So I like all the participants once again for the valuable support. Thank you.